Can you see my screen?
Yes, yes.
So yeah, so we begin with so before we begin, two things, guys. I have a bad throat, and secondly, I have a bad internet today. So all my signals are just showing half. Okay, all my Geo as well as my hotspot. Both of them are very weak. So there may be lag, or there I may just get out. Okay, it might just throw me off. So I do have problems today. But whatever, we can finish whatever we can. Okay. So today's topic is electricity. One of the I would say a very important topic, but very dry topic. Okay, because frankly, architects wouldn't know head or tail of electricity. It's too much of physics, too much of understanding the this thing. But as I keep telling you guys, हमको उसकी चिंता नहीं करना है, because I am not training you guys, and neither I'm worried that if you don't understand the physics of it, but just understand the spaces required for it. But more or less, from the general knowledge point of view, it's important how to understand what to put where, why you need to put that, what are the components in the planning of electricity in an architectural design, and how would you do the drawings. Okay, so that is very important, and that's what we are going to study. And this is, I think, one of the only topic which will not have any drawings to be shown, or maybe I can show you the drawing part of it. Okay, but not like a case study. I mean, how do you show a case study of electrical application? It's everywhere, right? You see it in your own homes. You get out of the in your lobby of the building, and you will see that the wires are running here and there. Somewhere you will see that it's very well planned, okay, where you have a duct and all the wires are being taken through it. While in some places, like you see at our KRVI, wires are running helter and skelter everywhere. Okay, they are hanging, they are there, they are nailed to the wall. You have the conduits running on the staircases, and then the cobwebs within it, lizards behind that, all kind of natak. So you know what to do. If you want your building to be clean, tidy, beautiful, functional, and very easy to maintain, you need to give a place to these wires. You need to give place to these ducts. अपनी अपनी जगह दे दी, वहां पे बैठेंगे और आराम से अपना काम करेंगे और आपको दिखेगा नहीं. And that is the beauty of the planning. Okay, Swati, are you recording?
Yes, Meena, I've started the
Okay,
recording.
right. So we begin with electricity. So obviously the first thing is you all need to know that what are the and you know that. Okay, this is just a kind of a brush over, because most of you are from the science kind of science line, and we have done electricity in 8th, 9th, 10th, 12th, I guess. So, well, these are the generation, this is how the electricity is generated. You have thermal power plant, you have hydro, nuclear, diesel. Okay, so please do not think these and these are matching. Huh? This is one and this is one. Okay, so you have nuclear power plant, you have diesel power plant, gas power plant, combined cycle plant, solar, tidal, wind, geothermal, biomass, and fuel cells. Hmm? Fuel cell is the very new technology that is kind of related with the biomass, but done very differently. Biomass is from basically from your waste production, which we also get biogas. Okay, while fuel cells is from the agricultural kind of output that you get, and then how do you then convert that into fuel cells? So this is how various ways. So these are kind of a very clean kind of energies. Because natural resources are being used, while these is where we are actually using the resources which are very finitely available, not infinite. While these are infinite, okay, you can go on using them, and there will be no end to it. So the shift should be from this side, from the left hand side to the right hand side. And if this happens, so it's going to be a complete win-win situation. Automatically, climate control will happen, and a lot of other good things can start happening if this transformation happens. Okay. This is the energy resource map of India, where it shows you where what electricity is produced. Okay, you can get Google this. Really not material for us, but this is just a general knowledge. So you can see where there are mountains, where there are rivers, flowing rivers, okay, or you have the falls kind of a thing where you have the water is just flowing down, gushing down. You will have hydro plants, right? So you have hydro potential in the north and the eastern because both of them are very mountainous. So entire your Himalayan range can be a hydro kind of a project, okay. Coal reserves mainly in the eastern region. We know that there are famous coal fields here, okay, Jharkhand, West Bengal. These are the famous coal mines here. Part of Orissa also, I don't know, but maybe it's small. Distribution of energy resource and consumption centers are extremely unbalanced. So you can see that the distribution are, I guess, these red ones. Okay, so they are not really well proportioned. So anyways, what we are trying to say here is the electricity grid that we talk about. How do you get electricity? आपको electricity grid से मिलता है. It is not something that Mumbai is producing और आपको मिलता है. So there is this Dahanu plant which is producing, and the entire radius, okay, right till Bombay or utna hi on the other side of the Dahanu, people are getting the electricity from that, okay. So it travels from way beyond your imagination, somewhere outside, and all that costing has to be then put into it. That is the reason why electricity is so costly, okay. And water is like given to you at such a highly subsidized rate. So how do you understand electricity? Okay, मुझे थोड़ी तकलीफ होती है. I'm not very comfortable with understanding electricity. Okay, so I will compare it with water supply. Okay, so sources of water क्या होता है? Lakes, rivers, ponds. While what are sources of electricity? It's so hydro, solar, wind, tidal, thermal. जो अभी हमने बात किया, right? So we talked about and the other finite resources as well, where we talked about gas and thermal and all that thing. Uh, Water can be seen and felt. Electricity cannot be seen, but definitely felt. Huh? You will feel it if you touch it, and if it gives you shock. Nani yaad aa jati hai na? Water is made of water molecules, while electricity is nothing but a flow of electrons. How is it carried from source to the city? Huge pipes or conduits that we have seen in second year, right? So that you will have lakes somewhere like Vaitarna and Bhatsa and Vihar and Pavai, and all those lakes are there. And of course, Vihar, Pavai are not now used mainly for water supply. They supply it mainly to the industries. But nevertheless, you have the other lakes which are there, and from where the water is carried in those huge, humongous, giant-looking pipes, which then goes to your reservoirs. From there, it is supplied to your homes, right? How is electricity carried? So you might have seen those overhead tension wires or cables that is running through the city. Okay, it kind of really mars the landscape. It looks horrible, but well, they are the sign of development. Okay, we consider it कि जहाँ पे वो दिखता है, that means electricity is easily available. People are now thinking of going underground, but underground is a little costly because for the simple fact is you lay down the pipe, suppose, okay, and tomorrow the city is growing, city is going out on the fringes, jahan se obviously the lines are coming in. Now if somebody doesn't know, and we have this great I would say inefficient method of laying down pipes, we don't mark it on the road, right? So nobody knows what lines are there under the road, upar pura surface rehta hai. Now in many countries there are methods by which they can actually understand. So they paint it with orange bands and yellow bands and all that, so that people know that orange band ke niche aapko electricity hi milega. I mean, of course they have their own color codes and everything, but we don't have that, right? So you dig up anywhere, and then if you're lucky you will get the line, otherwise you dig more. That's where the we say that if we consider the digging of the roads in India, it would circle earth probably 101 times. Itna humne digging kar chuke hain, and I'm talking only about the Bombay roads, okay. Imagine all around India. So it is that bad, okay. So it's unplanned, unthought of, not coordinated, not under one window. So when the gas lines are being laid, they will not coordinate with the water supply lines and the drainage lines and the electricity and the gas lines. Nahi, वो अपना ही काम करेंगे, okay. And in that doing, they would probably harm some other things. Now I'm going beyond this topic, but this is all about planning. When you're talking about infrastructure, the same thing happens in the building as well. If you do not plan your building, कल एक इलेक्ट्रिसिटी वाला आएगा, इलेक्ट्रिशियन will come, and since he doesn't know what has been done before, he will come and ask you to do some major changes which is actually not required. So there are methods of taking care and maintenance of your building as well that we'll study in the final year when we do the BMS and all. But I'm just telling you, see, this is what can happen. The services can people take you for a real royal long ride. So same thing happens here. So high tension overhead, आपको at least दिखता है. So nobody will dig there, है ना? And plus what happens is, wherever these lines are seen, okay, you will see that they are comparatively in an open land. It is considered that electromagnetic waves that come out of these high tension overhead cable is not good for human beings, okay, on a long run. So you will not see any kind of buildings around, okay. So that's how you will see them. Movement, okay, how is water moved? आपने pipes तो लगा दिया, अब पानी move कैसे करेगा? Either you give gravity or they move by pumps, okay. So from high point to low point. Similarly, electricity will move. अभी electricity will not move from high point to low point ना, वो तो electrons है. Electrons को कोई problem नहीं है कहाँ पे height है, कहाँ पे depth है. Okay, इसको उसको क्या चाहिए? उसको push चाहिए, and that is where we give potential difference applied, okay. So from high voltage to low voltage. So this is how the electricity will flow. That's why you have this 420 voltage, 215 voltage. Huge amount to be carried. अगर मुझे करना है, then I will either use higher capacity of pump so that the water flows faster and gets me the quantity, or I will use larger pipes. Right? दो तरीके हैं ना. Either I give big amount of huge radius of the size of the pipes, or I give massive pumps कि पहले छोटा pump था तो आराम से पानी जाता था. Now the water will move faster because there is a faster boosting capacity, and I'll get the same quantity in the same time. So there are ways of doing it. अब आप electricity कैसे करोगे? Same thing. Use higher voltage or larger wires, that is thicker cables capable of carrying currents. ठीक है? Same application है ना? So this is how your this thing looks. High tension overhead cables that I was talking about. I'm sure you have seen this. Anywhere there is urbanization, you see this. We call it symbolization of urbanization. है ना? So problem है ये. It looks bad. Now the problem of last this thing. How do you carry the large amount of electricity? Is this? And we studied this in our physics. With thick wire, and there will be more resistance because when you say it's a flow of electron, barabar, but it is 1 second, guys, just a minute. Sorry, guys. So with thicker wire, there will be more resistance, that we all know, right? Because the material will be more material. That means the flow, and material में सिर्फ electrons नहीं होता है ना. There are protons, neutrons, है ना? So they तो will remain there. It's only the electrons which gets loose out of those larger orbits that they have, and they start flowing around. So that is where the issues will start. So more thicker the wire, higher the resistance. Okay. Now when you have the resistance, there will be friction. Understandable, है ना? So when there is a resistance, there will be some kind of loss of energy because electrons are trying to flow and the resistance is there. That resistance will be seen in terms of heat. Okay. So hence, what do you do? We don't want that kind of a problem being occurred. Okay. So what we do is, hence higher voltage is used to carry. Okay. यहाँ पे मतलब higher pumps are used, not the diameter. Water में वो problem नहीं है. Okay. It's a cool thing, but यहाँ पे this is little volatile. So I can't say that I can use thicker cables. The moment I go for thicker cables, I will have loss of electricity, which is at a very humongous level, at the city level, which I can't afford. That is why, guys, you will see that the wires these wires are getting carried. See, they are very thin. Okay, they are not that thick, huge pipes. Imagine water pipe being hold up like that. But the voltage would be something like 11,000 watts. It's like that huge voltage. अगर हाथ लगा तो मतलब आपके bones भी जल जाएंगे. It is that bad. It's really bad. Yeah. So let's go one by one. Okay, there is, as I said, there is a lag. I've already changed the slide. Okay. What is electricity? It's a movement of electron, also known as current. Will electrons move on their own steam? No. They would need some kind of impetus, okay? And that is to say, some difference of charges. As I said, potential, higher potential, lower potential. Now, so what is this charge difference called? Potential. Hmm? Electrons try to distribute themselves uniformly throughout the conductor, and in so doing, it flows from one terminal to another. Thus, a potential difference is the pressure that creates current in an electrical circuit. We have done this in our physics classes, right? I'm really not going into the theory. I think I'm not the right person to tell you the theory about this, okay? Or rather, I've forgotten about it, because the source creates a potential difference from where the source emits electricity. Okay, it could be anything. It could be solar, it could be thermal, it could be nuclear, whatever. That force forces current through a circuit. Okay. Now this is called as an electromotive force or electron moving force, EMF, which, believe me guys, we don't have to bother about. What do I have to bother about? What is the potential difference that I am getting in my building at the start point of the building? That is really my concern, because if I say that, okay, I am going to get only 230 volts, then I will have a problem, because I would need a three-phase wire, three-phase, which is 420, 415, okay, so that my lifts will work, my pumps will work, my ACs will work, okay. So that's where my, what do you say, I will need more. So yes, I should be worried when I get that information, not about EMF. But ये general knowledge है. Current is the movement of free electron through a circuit under the influence of an applied EMF. Current flows from a higher point to a lower point, यानी point of higher potential to lower potential, which is very straightforward. Okay. Uh, Volt is what? Is nothing but the measure of EMF or potential difference. So basically, potential difference का दूसरा नाम है EMF, which allows the electrons to flow from higher point to lower point. Now, what is the current? Current is nothing but flow of electrons, okay, through a circuit. Now, how many electrons pass a given point in one side is something that will depend on the potential difference. जितना ज़्यादा है, उतना ज़्यादा current. Now, when a large number of electrons flow past, sorry, whoever has joined, I cannot, because we waited for 13 minutes, I really cannot go ahead with that. When a large number of electrons flow past a given point in 1 second, the rate of current flow is ampere. We know that, right? The unit of current is ampere. Usually in our day-to-day life, current is measured in 5 ampere or 15 ampere. Larger ampere means more current. Okay, that's why you will say that your refrigerator, your AC, your boiler will require larger current. They don't require three phase. Now please understand this. Huh? कोई भी apparatus in your building do not work on three phase. They all work on single phase, but it's that they require larger current. That is why we have chota plug and bada plug. Remember that? And you have thicker wire and a thinner wire. So that is where you will say 5 ampere plug and a 15 ampere plug. So that's why your refrigerator जो plug है वो बड़ा रहता है ना? Oven का plug बड़ा रहता है. Your boiler का plug बड़ा रहता है. Today you get boilers working on 5 amperes also, but you have a boiler at your place which is like those huge boilers, capacity of having 4 to 5 people having bath at the same time. Those kind of boilers will definitely need 15 amperes, okay, because the heating always takes more electricity. Cooling always takes more electricity. That's why your AC will also have 15 ampere. So please understand the difference between three phase and ampere. Three phase we use where the load of the entire building इतना heavy है कि वो single phase burn out हो जाएगा. So then what I do is, if my load is say 900 something, okay, I can put it on three phase, okay, and I can say 300 ये phase को देगा, 300 इसको, 300 इसको, and accordingly I'll wire my entire building. So that's why sometimes you will see in your own building, आपके घर में इलेक्ट्रिसिटी नहीं है, लेकिन बाहर के लॉबी में इलेक्ट्रिसिटी है. That means your phase, the phase on which your house is built, has gone out, but the other phase is still working. Okay, so that is how and we'll do that in the distribution. But I'm just trying to tell you, do not get confused when somebody asks you कि AC कौन से phase पे चलता है, single phase पे ही चलता है, तो उसको 3-4 वायर उसको आएगा नहीं ना. Okay, but it requires higher ampere. Free electrons pick up velocity in their movement along the conductor, converting potential into kinetic energy of movement. Okay, and that's where I have to take care. Now, before the electron has gone far, it collides with a relatively larger metal ion. बराबर है, electron move होता है मतलब, you understand now what I'm trying to say. You have a atom, right? Atom has a nucleus and has orbits in which you have your electrons. Now once the electrons get lost, okay, they free हो जाते हैं, it becomes positive ion because यहाँ पे अभी protons ज़्यादा है, right? So in that case, okay, you will have a positive, relatively large metal ion, and that is where my resistance come in. An ion is simply an atom or group of atoms, okay, which by loss or gain of one or more free electron has acquired an electric charge, right? Now, as a result of collision between free electrons and ions, the free electrons give up some of their kinetic energy to the ion in the form of heat energy. आपको क्यों ऐसा लगता है कि boiler can run on electricity? For the same reason, okay? The same application is done there. So what happens is you have a metal conductor within your boiler, okay? So जब आपको electricity देते हैं, there is a very fast movement of electrons, and when that electrons move fast and there is no end to it, it is not supplying, it is just running in between. That means there is a larger creation of heat energy because it is not going anywhere. वो उधर का उधर ही घूम रहा है. And so what they do is they start giving up energy in terms of heat, and that's how you get your water boiled or heated up. Same thing here. Now that is why a conductor feels warm to touch when a current is passing. Now this can become hot when the current is passing too often and without any giving away of electricity. If the amount of heat produced in the conductor is more, then it can dissipate. यानी वो डिसिपेट नहीं कर पा रहा है, वो अंदर के अंदर ही उसका वो हीट इज बीइंग स्टोर्ड इनसाइड, देन देयर इज अ प्रॉब्लम. Then there is a massive problem, guys. यहाँ पे you will come in, okay? Because you guys, as an architect, will see to it that the clients, the building you have done, and the people who are residing in that will be safe from these kind of hazards, okay? Now, when the conductor, if the amount of heat produced in the conductor is more, then it can dissipate. The temperature of that conductor will rise to create a fire hazard. Why? Because you see those white color, blue color के plastic thing over the pipes, right? Over the wires, है ना? Wire तो खुला नहीं रहता है, touch करेंगे तो shock लगेगा. So we use something called as insulators to keep these wires safe. Okay, now if the heat is more, it's basically plastic, na? The plastic melt hota hai. And then the problem starts when two plastic melts, or jab do live wire comes in contact with each other, boom, there is a short circuit and fire can start very easily. So the biggest problem with electricity is it can convert itself into heat very fast, and that's where the electrical guy, the electrician, will have to take care of. Okay, this is also called as loss of electricity. Okay. Now, since current is the movement of free electrons, the collision opposed current बराबर है resistance बोलते हैं. Resistance is that property of an electrical circuit which opposes current. I hope you understand. It's very easy. Conductor है, it has atoms. It's made up of atoms, molecules, and atoms. Okay. Once the electrical potential motive force is, यानी कि potential difference is applied, okay, electricity starts flowing in the way that the first atom of the conductor. Why am I actually even explaining this? This is all physics, but what I'm trying to say is understand the concept of resistance. Basically, thicker the wire, higher the resistance. Okay, if the conductor is extremely good, like copper, that's why we use copper wire. Copper wire has least resistance because it's very fast. Okay, but if you say you use some bronze wire, or if you say some brass wire, not only they will be very costly, there will be lot more resistance created. Or imagine iron wire. Okay, the resistance will be higher. Okay, so that's why copper wire are the best wires that can be given. So even if you know आपके घर में कहीं wire पड़ा है, you take your cutter, and if you remove the insulation, you will see copper wire within that. Okay, they are the best. Now, since current is the movement of free electrons, the collision oppose current. Collision with what? With the ions. Okay. Now, resistance is that property of an electrical circuit which opposes current. Now, unit of resistance is ohm. Now, why do I say this? Because this is where your formulas will come in. What is the relationship between volts and ampere and resistance? Voltage is V. Okay. Current is, so voltage is equal to current into resistance. ठीक है, impedance का दूसरा meaning है resistance, और current is equal to voltage upon resistance, है ना. ये basically if you understand this formula, then you can do anything, है ना. ये तो आपका simple maths है. So current will be resistance नीचे जाएगा. If I just take resistance, then voltage upon current will be the resistance. So whatever. So remember, C is equal to V upon R. I is equal to V upon R, जो हमने physics में किया था. More the voltage, higher is the current. More the voltage, lesser the resistance. Hence, higher the current. समझे आप क्यों? Voltage ज़्यादा है ना? So that means the resistance will be more. यहाँ पे देखो ना, है कि नहीं? So if I say voltage, you can see from the formula, the inference of this is from the formula. So these are some of the electrical formulas that please take a screenshot of this. Okay, I can share this wala this thing with it, but mostly I am not of the kind to share this thing, because in this online mode, what I have realized is people then stop attending my lecture, or my lecture, nahi, in anyone's lecture. Once we say that we are going to share this PPT, problem hota hai. So please guys, pay attention. Take screenshots if you want. I don't mind. Okay, write this thing, listen to the lecture, make notes, whatever. Okay. What is energy consumption? आपका जो electrical bill आता है, okay, it is the unit, right? It is this kWh. So energy consumption is nothing but wattage into hours of operation per year or per month. In our case, the bills do not come annually. We get monthly bills. Okay, so it is per month, whatever. ठीक है ना? So hours of operation per year अगर मुझे calculate करना है, so please start writing, guys. I'm going very slowly. Open your notebooks, take out your pens and start writing this. The more you write, the more you will understand. Hours of operation per year is equal to operating hours. Suppose college is running from 8 to 3, okay, the normal times. That's about 7 hours, okay, per day, okay, into operating days. हम कितने दिन चालू रहते हैं? 6 days. So let's take the case of KRVI. We run 8, 9, 10, 11, 12, 1, 2, 3. Yes. So we run 7 hours into 6 days. Okay. Into operating weeks कितने हैं? So we have 1 month of कैसे कहते हैं आपका दिवाली, 1 week of तुम्हारा Christmas. Okay. Maybe a month of your this thing. What do you say? Summer vacation. I mean, you guys go off, but we have only 1 month. Okay. So 1 month is 4 and 4 and 1. So that is 9 weeks off. So total there are 52 में से 9 cancel किया तो कितना आता है? 2 and 7 is 43. चलो 40 पकड़ते हैं. Okay, with some holidays and all that. So we say that this. So operating hours is 7. Operating days are 6. Operating weeks are 40. Got it? So this is how you will get your hours of operation. समझ में आया ये बात? Guys, please respond. Unmute yourself, and some of you say yes, no. I'll explain this again if you don't understand. You can actually calculate your electric bill based on this, and fight with your guys if the electric bills are more. If you know the wattages that is there. Got it? So this is how you will. So hours of operation is this into wattage. अब wattage आप कैसे calculate करोगे? that I'll show you आगे जाके. But every instrument, okay, whether it's a light, whether it's a fan, AC, refrigerator, bulb, computer, everything will be given a wattage. ये कहाँ से मिलेगा आपको? Manufacturer से. So if you are buying a Philip bulbs, उसका wattage अलग हो सकता है. If you are buying say किसी और का, तो you will have a different. But generally when they say 60 wattage bulb, 40 watt का bulb, 100 watt ka bulb or a 0 watt bulb, okay, you know that this is the wattage. So bulb is easy, but not so when you buy. You don't say I need 24 watt ka tube light, or you don't say I want 36 watt ka tube light. You say white tube light or yellow tube light. You say 4 feet का tube light या 2 feet का tube light, है ना? So हर एक का specification भी अलग है, because we have been used to that system. You don't go to a shop and say मुझे ना exactly 50 watt का PC दे दो, हंसेगा कोई आप पे. What do you say? I need certain RAM inside, certain memory, certain speed, blah blah blah. जो भी आपका configuration है, you will have to go and say. So every instrument has a different way of specification when we go and buy. But nevertheless, when you buy a PC or a laptop, when that जो box आता है ना आपके यहाँ पे, उस पे लिखा जाता है कि ये कितना wattage आपका consume करेगा per hour, per whatever, वो उनका रहता है. But so based on that, you can calculate the wattage your PC or your laptop or any instrument that you have bought will consume when you run for that much time. Okay. So that you get from the manufacturers. So just for an example, if you can, even if you don't need it, if you go today and buy, say, a small tube light, नहीं भी लाते हो, just go to an electric shop, order for a, मुझे सिर्फ देखना है, and then वो जो पुट्ठा रहता है आपका इलेक्ट्रिक का, मतलब ट्यूब लाइट का, उसके ऊपर लिखा रहता है all your manufacturing details specification is written on that box of tube light. Okay, similarly on all other instruments. Yeah, so this is how you will do energy consumption. Lighting system efficacy is lumens per watt or LPW. When I say lighting system means I'm getting more light. Lumens is light, right? So I get more light. So that means I have to see that if I have 100 square feet, now if I use a bulb, I will get say 5 lumens. If I use a tube light, I will get say 10 lumens. If I use LED, I'll get say around 7 lumens. Okay, so 5, 7, 10. Okay, now, but how do you know which is good system? Then what you do is you compare the wattage. Okay, फिर आप बोलोगे मैं 5 lumens मिलता है when I spend 60 watts, तब जाके मुझे 5 watts 5 lumens मिलता है. I'm just giving you an example, ना guys. If I'm using LED, I'm using 10 watts. Okay, and I'm getting 7 lumens. Tube light is giving me 10 lumens, but उसका wattage है 36. ठीक है, अब which is most efficient? LED, right? 10 watt में मेरे को 7 मिल रहा है. So then even if I double, so that now 7 plus 7 14 हो जाएगा, मेरा watt still is 20, which is lesser than tube light and bulb. So then obviously I will go for LED. That's why you need to know LPW. You do this comparison, okay, and you get your stuff. So system lumen output is divided by input wattage. As I said, कि आपको कितना output चाहिए, lumen कितना चाहिए, okay? तो उसको आप divide करो wattage से, आपको idea मिल जाएगा. Unit power density, I don't think so you should go into it. I'm just writing this. You can have a look at it, okay? Density and all that is definitely used by these electrical guys, because more the density, they will have to take care of the wires and the insulation. So that's why they do that. Not generally used by architects, but I am interested in all the red color ka jo mark kiya hai. I am interested in that. That is where my concern is. And of course, I forgot to mention this lux. That should also be colored red, because as a lighting designer, lux becomes prime important. That is what you will provide to your clients, and that you need to know, understand, and then accordingly you will do your lighting layout. Okay, so yes, this should also have been red. What is basically we did that volts into currents into power factor. Okay, now what is a power factor? Power factor is basically a factor which you multiply to kind of, I really don't know how to explain this. anyways, I'll when I get a proper this thing, I'll let you know. Okay, I'm right now not getting proper words. Voltage is basically we did this. Okay, foot candles. One lux is basically 1 foot candle into this. So basically, lux is total lumen divided by area in square meters. As I said, this lumen is nothing but the output from a light. इसको जब आप स्क्वायर मीटर या स्क्वायर फुट या स्क्वायर इंच से डिवाइड करते हो whatever your area and whatever units you use for your area, you get lux. Okay, and this is what we really look into when we do the lighting layout. Okay, uh, any questions? होना तो नहीं चाहिए because there's nothing really questionable here. Distribution of electricity. Now, this is where you come in. This is where I will really enter into the picture as an architect, because I need to give spaces of meter rooms. I need to give spaces for ducts, where my conduits are going, how they are going. Do I give horizontal duct? ये सब आपका काम है. Okay, so please understand this. So let's once do at the city level, and then we zoom down to the building level. Now, generator produces electricity. We know that most countries have what is called an electrical grid. Okay, this consists of many wires carried across the country on large pylons that you saw. I showed you the picture of those overhead cables which link the generating stations and distribute electricity. Okay? So basically, from the generator, wherever the generation is, say for Mumbai, we have it from Dahanu. And you will have these overhead cables running also when you go towards Ahmedabad, Surat. Okay, you see these running along with your train. You know, so those pylons carry electricity to Surat as well as to Mumbai. Uh, so this is where how the electricity is done through it. लेकिन कैसे होता है? Now the demand for electricity is estimated at a regional control center. Hmm? What is regional control center? So you have a region. A region is basically demarcated by various ways. Okay, so again, that's a very planning kind of a thing. So region can be demarcated by, say, geographically. आप demarcate कर सकते हो. You can do it politically. You can do it socially. You can do it sector wise. Maybe some area is purely industrial. तो वो एक zone हो जाता है ना? Regional हो जाता है, एक region हो जाता है. So in generally when we do for the electricity, it is political in the sense who pays the bill from where. पैसे का rule होता है. Okay, so there is no kind of a geographical inference here or any kind of correlation with geography and social and all that. Clear cut hai who pays the bill and how that bill and the money is generated. Okay, so it's very political and boundary oriented. I wouldn't use the word political, governance I would use the word. Okay, where it is decided which generators will be run and which will be brought in use as the demand increases from whichever area it is. Now, means of the national grid system, a sudden excessive demand in one area can be met if necessary by generators many miles away in another part of the country. So that is how Dahanu is a part of Gujarat. Okay, but we get it electricity from there. So यहाँ पे Gujarat will not oppose and say नहीं नहीं महाराष्ट्र को हम क्यों दे रहे हैं, because this is decided. It's a national basically क्या कहते हैं property where Gujarat and Maharashtra is part of it. The generation of power is at 3.3 kV. Just see the difference, huh, guys. When I say 3.3 is छोटू सा है ना? kV is kilowatt and 11 kilovolt, but the voltage is then stepped up. What did I say? You have to travel long distance. So आप बड़े बड़े pipes लेते हो ना for water. If I have to carry from Vaitarana to Mumbai, the pipes will be so huge because I am supplying to the whole city of Mumbai. Similarly, the electricity is supplied to the whole city of Mumbai. I need huge amount of electricity coming in. How do I get this huge amount? Either I have very thick cables, but then what will be the problem? Big resistance. Big resistance matlab big loss of electricity. बहुत महंगा है ना? So then what do? I step up the voltage. Now look at the step up of voltage. Is step up 220 kilowatts. If I convert this into volts, it would be another 30 added to it. And it would be around 2,20,000 volts. Or 440 kilowatts. That is called like super stepping up, है ना? That's why you require those huge pylons जिसको कोई हाथ ना लगाए, okay? And all proper earthing is done and everything. So even you can see sometimes children playing there. we don't allow that, okay, but slums hai wahan pe, and we all know that wherever there are vulnerability, the slums will come up there, because slums have no options, okay. They are like, kehte hain na, it's very sad, but we say that na, beggars have no choice. Similarly, these people are so bichare, unke paas na ghar hai na paisa hai. Where there is land, where people, normal people will not go there, because we know this is not for us, it is dangerous, and we can afford to have houses away from it, so we buy those houses. But these people have no options, they will settle up there. So you will see many times, where was this, we saw this in Abhyudaya Nagar near Cotton Green, okay. Right where there is this huge pylon, niche hi aapka pura slum hai. And when you imagine the kind of impact the children will have over a long time when those electromagnetic waves are affecting their brain and bodies, okay. So yeah, it's a dangerous situation, but that's the part and parcel of life, okay. I deviated, but I'm coming back here. The voltage is then stepped up to 220 kilowatt or 440 kilowatt for long distance transmission. And then what happens is, once the transmit लेके pipe आ गया, अभी city में आ गया, अभी उसको receiving station चाहिए ना, इतना huge kind of a voltage is coming. तो जैसे शंकर ने वो गंगा का force लिया था अपने जटा में, similarly you require some kind of shankar here, and that is substation, okay. So substations ये force ले सकता है, so that's where the stepping down happens. अभी इतना force है आपके यहाँ पे आ गया है, अभी वो force को reduce करना है आपको, right? So how do you reduce that electrical voltage of 220 or 440 kilovolts? You have something called as step down transformers, okay, which is where do you keep these step down transformers? Into the substation. So you, that's why you see, नहीं तो आप बोल सकते हो ना, विरार में लगा दिया, एक दहानू से आया विरार में लगा दिया, एक substation is good enough. Now that substation can supply to the whole of Mumbai. Then why do I see this pylon happening in Chembur? Why do I see the same pylon happening at say Cotton Green? Because guys, substation can only handle little bit, है ना. तो वो क्या करता है, various, so again within a city we divide it zone wise, okay. And so we have, for each zone we will have one substation. That's why the wire has to come right till the end, till the last substation is there. So that's how the distribution of electricity happens. So one probably is at Virar, then central mein probably it is at Mulund somewhere, then somewhere it is in Chembur, somewhere it is in Cotton Green, I don't know, it can be anywhere, okay. So where these are the places where you will have substation. So you say generation, then it comes via these huge pylons, then it has your substation, various substations in the city. Now if I take a zone, chalo hum hamara K West ward lete hain, KRV hai, so there will be some substation, say maybe in Santa Cruz ya Parla ya Andheri, I don't know, somewhere there will be a substation, and from that substation that entire locality which for it is designed will be given electricity, okay. So this is how distribution happens at the neighborhood level, at the city level, at the region level, okay. Now after reaching the substation, it goes into something called as a step down. It is step down, so that we receive a power of 230 volts at all houses, okay. This is how it happens. So you have national grid, यहाँ से आपका लोकल आता है, फिर स्टेट एंड देन लोकल, ठीक है. लोकल नहीं, सॉरी, रीजनल आता है, देन स्टेट एंड देन लोकल, ओके. नाउ दिस इज व्हाट दे हैव, दिस इज हाउ वी हैव प्रोग्रेस्ड. इन 1950 वी यूज्ड टू हैव लोकल सप्लाई, हमारे पास कोई ग्रिड नहीं था, ओके. वी यूज्ड टू हैव समथिंग कॉल्ड एज लोकल. 1960s we started doing electrical distribution at state level. That's why we had BST, right? बेस्ट जो बस के हिसाब से जाता है. पहले आई रिमेंबर व्हेन आई वाज अ किड, वी यूज्ड टू गेट इलेक्ट्रिकल बिल फ्रॉम BEST. That was at 1960s. Not that I was born in 1960. I'm not so ancient, okay. But yeah, it's this is how it happened at state level. 1970s में आपका regional चालू हो गया. That means now you started getting from a regional area, maybe. So you can say a certain part of Maharashtra and certain part of Gujarat came together to form one region, and you would have a centralized Dhanu from which it gives to both these areas. but only till Mumbai, and यहाँ पे only probably till Maharashtra or Raigad. Then beyond that, there will have to be another region which will be supplied through another what do you call generation. Okay, and then finally 1990s you have national. So
Meena,
this is
sorry to
yeah.
actually slide hasn't changed for me. It's still on the national grid system.
मैंने बोला ना, I have a very bad internet today. Bad
Yeah.
internet and bad. Now how do we go ahead? It's not changing. Just give me a minute. I'll get out and come back again. Can you see my screen, guys?
It's still stuck at
The
distribution of
same.
electricity.
Okay. I have already went out and come in. Maybe I'll have to exit totally and join back again. Is that fine? Because otherwise there is no option. And I don't know what to do.
You can try to reshare, like stop sharing and share it again.
Maybe 1 second. Okay. Super bad internet today. I couldn't even send WhatsApp messages in the morning. Is it being shared now? Are you seeing something or it's the same or a blank?
It's a it's a blank screen.
Awesome. Okay. So what do we do, guys? This is not moving and it's not being shared. I've shared it again. So Swati, I'm trying to send it. If
Yeah.
this thing allows to send it, then please you share.
Yes.
But as I told you, the internet is so slow कि इतना heavy file जाएगा कि नहीं, I don't know.
You
And
think
even
it'll help if you just give it like a few minutes to come back? I mean, to stabilize. So maybe if you just logged out, it'll.
I opened up my windows, my door, from wherever it comes, but nothing is happening. Even the Gmail is just buffering. I have a major class of construction also after this. Okay, so I'll do this. I'll take a 2 minutes break. I'll get out of all this and I'll join after 2 minutes. Just bear with me, guys. I can really help it. Yeah.
Oh, okay. Yeah, we can see it, Meena. We can see the
Okay.
slides.
Ah,
Yeah.
thank God. Finally. थक गया था बेचारा उसको रेस्ट चाहिए था. Anyway, what to say. Anyway, so guys, so this was what I was talking, huh? So 1950s, you can see it was local. Then 1960s, it became state. 70s, regional ho gaya, and 1990s, it went grid. So some years back, I think it was in 90s only, since the grid was new, and I think I was in, I don't remember which year of architecture I was, but the whole of the Delhi region. So the Delhi till Haryana se leke till Uttar Pradesh tak, that whole is in one grid, I guess. And that entire area went under, like it was like a war being declared, and wo jo darkness hota hai na, that kind of thing was seen. Okay, it was very highly scary because this is what can go wrong at the national level. If something goes off, the whole of the area will go blank. Absolutely, kahin pe kuch nahi bachega. So this is where the disadvantages of national is. But then national becomes, it has its own advantages. Though if you ask me personally, sustainably, if you see, local is the best. Okay, and that's how it should be done. But then it has its own governance issue, political issue. So that's why people go for grid. Now, coming to the distribution of electricity, to avoid losing energy in transmission, हमको पता है हमको voltage up करना है, ना कि हमको wires thick करने हैं. Like what we did in water, we don't do it in electricity. Okay, larger the pressure, larger the flow, and also the resistance met is less because हमने wire का size change नहीं किया. We are keeping thinner wires so that the resistance is low, but we are stepping up the water. ठीक है? And then it is transported to the place where it is to be used from the place of generation by huge cables. So I'm just capping it up. It comes to the transformer station where again it is stepped down. From there, it is led to the substation where it is distributed at area level. And then now generally transformer station, I didn't say in the previous because generally transformer station and substations are more or less एक ही जगह पे होते हैं. You don't keep it at separate place, right? Uh, from there, it is led to substation where it is distributed at area level, and that's how the reason it is stepped up so hugely is because resistance is inversely proportional to voltage. That is more voltage, less resistance. So this is the formula. Please remember this thing that I've highlighted here. Uh, so voltage increases, current increases. Okay, resistance decreases, current increases. Okay, so idea is you decrease the current. Voltage is equal to current upon resistance, right? V is equal to I upon R. So that is how you will remember this formula. How is the step up and step down done? Through transformers. Okay. So this is how the voltages are used. Can you see the change here? So 1950 कितना छोटा है देखो 132 kilowatts. Then it came to 1959, it was 220 kilowatts. In 1977, the step up was done to about 400 kV. This means that more and more technology became more refined. Okay, there was innovations, and that's how they could afford to raise up to such a level of voltage. In 1990, when it went grid wise, the step up was around 500 kV. Okay, 2000 765, and today 2011 it is around 1100 800 kV, and we were talking about 440 kV. So yes guys, with more and more demands in electricity, this is what is going to happen. So definitely it works way better for humans, for planet, for environment to go for local and green energies. Okay, so imagine if you have solar panels installed in your entire building, on your house, in your and that is exactly what high rise buildings are doing. Okay, so I just finished a lecture with envelope design for high rise in fourth year construction, where the idea was that even the windows, the louvers of say toilet, okay, or louvers of the entire building will probably have these chota solar panels, and the amount of electricity it can generate can run entire building. Okay, at least the common areas. Okay, which is so huge in a high rise building, absolutely free of electricity. So that is the power of going green and going local. Right, so this is how it, these are some of the ways. So you can see a dirty looking kind of things that we see near stations generally. Okay, you will see this when you travel by train, especially, I mean, I travel to Ahmedabad, my country, I mean my hometown. So if I go there, I would see that I will see these at Surat, I will see this at Baroda, I'll see this at Valsad, okay. I'll see this at Virar. So all these places you will have generally this, because these are also supplying majorly to your railways as well, okay. Of course they have DC, so of course a part of it will be DC. So that's how it is done. So this is how a normal transformer and substation, which are generally clubbed together, seen together. And you will see it fenced with a skull and that bone saying that dangerous sign over it. So it's completely off the grid for people. Okay, did I not go full screen? Yeah. Okay, now coming to the neighborhood level. Now यहाँ पे you will now, this is now our arena. ठीक है, now architects come into picture. How do you do distribution at building level? So you might have seen right outside our building, apna KRVI, okay, there are these few red boxes. Now, problem kya hai? Red boxes are of two kinds. One, even the telephone MTNL guys use, and one electricity guys use. So दोनों ने red color choose किया है. I don't know why. Maybe because they are very obvious. Even at night time, the red color is seen very obvious. So accident nahi kare. Probably that is one of the reason, I think. Plus, it is also danger sign. Red means don't touch. है ना? Red signal, ruk jao. All that kind of stuff. So, how do you then recognize that this red box is belonging to MTNL and this red box is belonging to electricity? Simple hai. They have that symbol of danger. And what is the danger? A signal is that you have a crossbone and a skull there, okay, which shows that do not touch. And if you touch, it is your own responsibility if you die, okay, because we have put a warning sign there, right? So at area level, so what happens is generators, generator से आपका you have those pylons through which your electricity will come at an extremely stepped up voltage. It comes down to the transformer, substation, it comes down, and then वहां से तुम्हारे सारे wires are being taken through these large conduits. Now these large conduits have to go everywhere. It has to go to KRVI, it has to go to तुम्हारा क्या कहते हैं कैफी एसबी पार्क का जो तुम्हारा लाइटिंग है दैट एरिया, सामने वाला विद्यानिधि स्कूल, पीछे वो क्या है तुम्हारा बाल मंदिर समथिंग देयर, एंड देन आगे जाके यू हैव अनदर फ्यू स्कूल. नाउ एवरी बिल्डिंग ऑफ आवर एरिया, गुलमोहर रोड एंड अराउंड KRVI विल हैव टू बी सप्लाइड, राइट? अब एक एक वायर आप कितना लेके जाओगे? सेम थिंग व्हाट वी डू इन वाटर सप्लाई, वी डू इट at the electrical level. But since electricity is highly क्या कहते हैं dangerous rather than water supply, okay, electricity can kill people, so we have to be little bit more careful. So what they do is, instead of having reservoir one for the whole of the neighborhood, they have reservoirs at various levels, ताकि अगर वो burst हो जाए तो प्रॉब्लम ना हो जाए, राइट? सो दैट दोज रिजर्वॉयर्स आर योर फीडर पिलर्स, है ना, नाम ही है फीड करता है. It feeds to a certain number of buildings. So after every number of buildings, you will have another feeder pillar, okay, which will be supplied from the same substation. So say you have one substation for K West Ward. Now the whole of the K West Ward will be filled with numerous feeder pillar, okay? So remember that. So feeder pillar is nothing but a smaller substation through which your building and surrounding buildings are getting feeded electricity. ठीक है? Distribution at building level क्या होता है? Now how does this building में wire कैसे आता है? So from the feeder pillar you take one conduit and that conduit comes into your building. Now within a building, electricity, I said, okay, the conduit comes in. Now you know electricity is dangerous, so I have to be very, very protective about that conduit. So when I'm taking that conduit, where will you take that conduit? Can I take that conduit and directly supply to 403 where I am staying? No, or 412 where somebody else is staying, or 430. I don't know. I cannot do that, right? Because along with 403 and 11 and 12 and 15 and 16, I have to supply to the pumps which are taking the water up to my building, in your building. There are terrace lights, there are stilt lights, there is ground floor lights, there are lobby lights. ये सबको कौन देगा? And from one wire, how will you separate it out? Okay. So same thing what we had in water, we will do it here. That's where I give you the analogy of water supply. It is similar, almost. ठीक है? Now see this. हमारा water supply में cutout क्या था? What was the cutout in water supply? Just read the sentence. Within a building electricity, electricity passes through a cutout, which is a fuse kind of a thing. Okay. In case if bills are not paid, cutout is simply pulled out and electricity is cut off. What was the cutoff in the water supply? If you don't pay the bills, anyone remember?
Stopcock.
Yes. Stopcock कहाँ पे रहता था? तुम्हारे बिल्डिंग में कि बाहर?
Outside the premises, like near the boundary wall.
It will be outside the premises, not necessarily near your boundary. It could be anywhere, but it's supplying to you. So it could be cut off for the, so BMC can come and just take out, just stop the stopcock, lock the lid and go out. And you will be without water. Okay? We also have one within us, है ना? Within our building. वो किसके लिए है? What if I don't want BMC water? तुम्हारा पानी हमको नहीं चाहिए because it is polluted, which is dirty, it is whatever, okay, and I don't want it. So then you can stop the cork and not allow the water to come in. So that is your control point. Okay, so this is how we also have the control point in the electricity. Okay, जिसको हम we have double pole switch in our own homes. So when I go out of say मैं 3 महीने के लिए I'm going for a very large tour. Okay, why will I put the electricity on? I will empty my fridge. हाँ, distribute करके 3 महीना है ना, fridge क्यों चालू रखना? I'll distribute everything, and then what if I have to say that electricity cannot be charged to me? Okay, I'll push off the double pole switch. I'll tell you what it is when I come there. But I'm just telling. So these are similar to what we did in your water supply. Just I will be going back to water supply and coming back to electricity for you to understand the system well. The next step is a bus bar. Okay, understand these words, bus bar. Okay, it is a, and this is the only where I can answer. I don't know what naam kya hai, kaam kya hai, mane, because I cannot relate this to bus, but it is called as a bus bar. Okay. The next step is this. Now it is nothing but a long strip of copper. Okay. Now why copper? So what do I do? From one wire, guys, I have to supply to, say there are 40 flats in my building or your building or anyone's building, or say KRVI. Okay. Now from the one wire, I have to take the lines to staff room, to library, to Paul's room, yani Manoj room, then you have office and all the studios, lobbies, niche ka pump, everything. How do I do that? It's magic, right? I cannot do that unless I have something. What we used to do in building for the water level, हम क्या करते थे? We supply water from the UG? No, right? We supply from the OHT. तो OHT पे हम क्या करते थे? We used to do something called as, मैंने लिखा भी है, just at a terrace level, looping of water line is done, right? So that infinite downtakes can be taken. Similarly, bus bar is nothing but a strip जिसपे मैं I can put numerous attached wires, okay, and the strip is, and I show you the picture, it has those nut bolt kind of fixing there. तो उसमें से I can take out numerous infinite wires that I need to take out, basically. Which are then taken to individual meters and then to fuse. Okay? Now from the fuse, it is taken to individual flats and to the main distribution board. What are all these? We will come to it one by one. So please understand. अभी बस बार से मैंने distribute कर लिया. Okay, from one wire, एक से अनेक हो गया. ठीक है? So now I have many wires. Now from all these wires are going to all these individual flats, right? Or all these individual areas. Now, please understand the distribution of institution level and understand the distribution of flat level or a residential level. Okay, बहुत फर्क है. I will not have MDB largely, or rather, I will have MDB only for my own flat, which will be very chotu sa. But you all have been to college. Hopefully, you remember. Okay, if not, next time I go to college, I'll take a picture and show you. I should have done it last time. I forgot. So you have the toilet area अपना at the first floor level, ठीक है, right in front of your fifth semester, fifth year का तुम्हारा studio. Now over that, okay, do you see a panel there? Anybody remember that? Big panel जिसमें से बहुत सारे conduits निकल रहे हैं. Anybody remember that? देखा ही नहीं, कभी याद ही नहीं आया. If you don't remember, and if you remember the staff toilet, okay, if you go to the staff toilet, if you are coming from down from the second year studio into your staff room, आपको staff toilet निकलता है. Staff toilet के ऊपर भी एक बड़ा सा panel है. Okay, I'll show you the photographs. Next time I go to the college, I'll remember to put it up. And I'll WhatsApp it to you guys so that the CRs can then WhatsApp it to you. Those are your MDBs, which is highly required in an institutional building because institutional building एक ही bill pay करता है. So it depends on the bill payment. Who pays the bill? Now, since in an institution, I will have only 1 meter because KRVI is the only guy who is paying it, okay? What I need to do is now I have a chunk of electricity coming in my area, but I need to distribute to various areas. Residential में उल्टा हो जाता है. Residential में क्या होता है? I take that one, from the bus bar, when I distribute it, what happens is, I can take that one wire, go to my meter, उसमें एक fuse लगता है, and then it will come straight to my area. Got it? And imagine the electricity I use in my area, my flat, compared to KRVI, there is a difference, right? I will use very chotu sa units, while KRVI ka bill 1.5 lakhs aata hai, right, per month when the college is on, right? So when I see this difference, there is a problem in distribution if you don't understand it, okay? So this understanding of distribution is highly important. We'll do this one by one. I'll be showing you diagrams where how this will come. If you feel this is going over the top, please ask me to stop. I'll stop. अपने पास बहुत time है, ठीक है? So we can stop. But this is how the things are done, ठीक है? So पहले होता है conduit अंदर आता है. Very safely, I will take this conduit, प्यार से, safely, I will take it to something called as a meter. Meter room is where I will house my bus bar. Okay, bus bar is nothing. Let me show you a bus bar. This is a bus bar. You see this? This is how my bus bar looks. It's basically various strips of copper जिसके ऊपर ये ऐसे fittings होते हैं. तो ये screws होते हैं. You can see this ना? The screws can be removed जिसमें आप अपना wire ऐसे घुमा सकते हो. Can you see my cursor? 1 second ना. I will go into the cursor mode. So now do you see this? And I will enlarge this so that you understand. ये दिखता है आपको ये ऐसा? You see this? These are all the, so these are the screws, okay, which you can unscrew them, attach the live portion of the wire, then screw it up. Now the contact is established between the live electrical wire and the copper. Now the entire copper strip is loaded with electricity. And like on this, I can take innumerable outlets like this. So just इसके लिए आपको ऐसा दिख रहा है. I can take wire number 1, wire number 2, 3, 4, 5, as many. Okay. So then it is how the design of the bus bar is, which you can definitely go in the market and ask for the specification. Now, do you do this? No. Best part is we don't do this. ये हमारे उसमें आता ही नहीं. ठीक है. What will be your BOQ में when you do your electrical BOQ? Will you say bus bar? No. That is not your job, okay? That is electrical guy's job. But what you need to specify is how that meter room is done. उसको कितना window लगाया है, उसको क्या frame दिया है, उसको कितना door है, वो plinth कितना है, उसको plinth पे रखना ही चाहिए. What if this thing is filled with water? So you will need to protect your meter room like anything, okay? So all those things is definitely your job. Now, if you don't do this, then you are stupid, okay? Plain forth, we all are stupid if we don't do this. So that is where your understanding for safety of the people will come into the picture. Okay, so you understood what is a so ये समझा आपको? Any questions till now?
The meter room can go on any floor.
No, it has to be at the ground floor.
Oh,
Why?
sorry, I didn't know, sir.
Why? Good question. Why?
Ease of access.
Sorry?
Access.
Excess, right? जो आपका बिल कैसे आता है? हर महीने आपका बिल आता है ना, वो क्या magically आता है? There is an electrical guy coming to your premises every month to read the meter, and then it is generated. So it's a big task for the electrical company. So imagine every area में कितने लोग उन्होंने hire किए होंगे जो हर area में जाते हैं, हर building में जाते हैं, and they see this, okay? And what if you have it under lock and key, and that security guy is not there? You know, it can be a pain and headache for those guys to come again and again and again, because office पता नहीं कहाँ पे है. And in this COVID situation, it was a terrible time for them to travel, and that's why we didn't get bills for about 2 to 3 months, right? And it was a loss for them. So you have to understand the implication at a larger planning levels. What happens when people don't, take the responsibility, and what all goes into it to provide you with this kind of infrastructure. You should every day get up from the bed and say thank you. You know, have this attitude of gratitude for getting an electricity at the touch of your fingers. You know, you just put on a plug and the electricity is there. I mean, and for that, so many people are working for you. So I mean, it's really amazing. And then, of course, there are issues of management, there are issues of corruption. But hey, where is it not there? Sab jagah pe hai na. Who says life is easier? So have this attitude of gratitude. Believe me, it will go a long way. Coming back to this, bus bar in meter room is basically copper strips with an outlet possibility. So this is where the main wires are cut up, and then yahan pe it's, I think, incomplete. There will be those outlets as well. Okay. Just as looping on terrace is done, so that various downtakes are possible from one pipe. That's how I've done this analogy. Any questions on bus bar? Best thing is you go today in your own building, open up the electrical room and figure out where is this. Okay, you will not see this because you can never see them open. है ना? Electric तो खुला रहता है room. कोई बच्चा जाता है. Generally we don't allow. That's why the security is there. Okay, but it is locked in the sense उसको कड़ी लगाते हैं, and the kadi is also at a higher level so that a kid cannot open it. So all this planning, see, these are all psychological planning. Only an adult can open it, otherwise any kid can enter that, and we can't keep it locked in case if that guy is not there, and if those guys come, it will be a waste for them. So all these things you will have to plan when you do this. Okay, छोटी छोटी बातें हैं, but then we are talking about people's service, right? आप सिर्फ लोगों को जो रह रहे हैं उसकी सर्विस नहीं कर रहे, also talking to the people who are coming from outside and seeing and reading the meters and all that. Now, coming back to this, bus bar is never kept open for the simple thing, agar aapne haath lagaya, you will be straight out. So we need to keep it in a protected manner. Generally, it is in a box kind of a thing from which you will see the wires are emitting, and then it will go here, okay? In places where you are assured that maximum security can be applied, you can keep it open. Then it can be open only when the assurance is maximum security is there. But still, why take chance? So you will see, that's why you see this rolls on, and this will be completely plastic, and no, even if somebody touches it, they won't be getting a shock. So that's how you will have to take care. One second. Yeah, I'll just. Okay, yeah. Any questions till now?
No,
Everything
but
okay?
yeah, but like you said, if it's, I think it's getting too much information now, and we need to process it to understand better.
अभी से अभी तो कुछ चालू ही नहीं हुआ है. What is the time, Swati?
It's 11:30, Meenal. We have 10 minutes.
Okay, fine. Then I think it's okay. Okay, so we meet next time, and actually it's good. Distribution needs to be taken at a complete fresh level. So we finish with this, and next time we start again at the distribution of the city, of the building. Okay? Okay, guys. Thank you.
Thank you.
Thank you.